In this lecture video, we're going to learn what a normal distribution is and go over some of the important properties of the normal curve. A normal distribution is a distribution of data having a bell-shaped graph, and a normal curve is the perfect bell-shaped curve representing a normal distribution, just like the one pictured here. The two most important features of a normal distribution are the mean and the standard deviation. The mean characterizes the position of the normal distribution. If the mean is a larger value, then the entire curve will move to the right. And if the mean is a smaller value, then the entire curve will move to the left. The standard deviation, on the other hand, characterizes the spread of the normal distribution. A greater standard deviation means that the curve will be more spread out, while a smaller standard deviation would mean that the data is less spread out. One example of a normal distribution is this idea of a population of 10-year-olds with a mean weight of 81.2 pounds and a standard deviation of 12.4 pounds. One important characteristic for a normal curve is symmetry. We could fold this graph in half and the left side would land exactly on top of the right side, and vice versa. This line down the middle is called the axis of symmetry. And where it meets the data line is called the center. In other words, the center is the point of intersection of the data axis and the vertical axis of symmetry. That's this point here. What's also interesting about this center is that it corresponds to both the mean and the median. If a data set is perfectly normal, then the mean and median will be exactly equal to one another. If the data set is approximately normal, then the mean and median will be approximately equal to one another. In this example with the population of 10-year-olds, the mean and the median is 81.2 pounds and serves as the center of the normal curve. Also notice on the normal curve that the direction of the curve changes. Near the center of the curve, the bend goes one direction, but on the edges, the bend goes the other direction. The 2 points where the direction of the bend changes have a special name. These are called points of inflection. We will label one of them P and the other P prime. And what's really useful about these points of inflection is that the distance between the axis of symmetry and a point of inflection is approximately equal to the standard deviation. So with this example of the weights of 10-year-olds, we have a standard deviation of 12.4. So the distance from the axis of symmetry to an inflection point is about 12.4. So if we add 12.4 to 81.2, we find that the location of the point of inflection to the right is equal to 93.6. And we can find the location of the point of inflection to the left by subtracting 12.4 from 81.2. or 68.8. The moral of the story is that we can tell a lot about a normal distribution just from the mean and the standard deviation. Those really are the key components for a normal distribution. That concludes this lecture video on the normal distribution and the key attributes of the normal curve.